Hello, myself, Professor H.K. Bhangade, Department of First Year Engineering, SND College of Engineering and Research Center, Eula. I welcome you all in a video lecture series of Basic Electrical Engineering, which is a course of first year engineering. So today, in this lecture, we'll discuss on Thevenins theorem. So the network analysis, for analysis of the network or a complicated circuit, we are using different tools for analysis. Analysis is nothing but to find out the various parameters, values of the various variables of the circuits like current flowing through particular branch or voltage across particular branch. So to find that, different tools we are using, and Thevenin's theorem is one of the tools we can see. Now, what is Thevenin's theorem that we'll discuss now? So the statement of a Thevenin's theorem is that the Thevenin's theorem says that any linear two-terminal circuit can be replaced by an equivalent circuit consisting of an independent voltage source VTH in series with a resistor RTH. So there's a standard procedure for finding the values of VTH and RTH. But the first, what exactly does this mean, and why is it useful, that we need to find out, that we need to study. So load, often an electrical circuit or a system, contains an element called the load. So that can be varied while the rest of the circuit or the system stays fixed. Now, any complicated network, here is the block diagram represents a complicated network that is consist of linear two-terminal circuit. Now, in between the terminals A and B, in between these two terminals A and B, load is connected. Now, this load maybe will, for experimental purpose, we can say any resistor, or in practically, there may be any load. It may be a bulb, it may be a machine, it may be anything. Okay, now example, what is load? I will give you an example that when you unplug a lamp, suppose across this terminal A and B, you have connected one lamp, which is lightning, that lightings lamp lightens your homes, and when unplug you that lamp and connected in between these two terminals a hair dryer, then obviously you have varied one small part of the huge electrical circuit that extends all the way back to the power plant. And the lamp or the hair dryer is the load, that is the part of the circuit. Now obviously the load being taken by the lamp and that of the hair dryer is different. So the rest of the network remains the same, but load it changes, and that depends upon as per the requirements. So the linear two-terminal network, this complex network remains same, but every time this load it changes. Okay. Now, what does the Thevenin's theorem means? Thevenin's theorem lets us replace everything on one side of a pair of terminals by very simple equivalent circuit consisting of just a voltage source and a resistor. Simply, what is Thevenin's theorem? Thevenin's theorem is that whatever this linear two-terminal network is there along with the load, so the whole network we can replace, or this linear two-terminal circuit or this rest of the circuit we can replace by a circuit which consists of one single voltage source VTH in series with RTH, and only vary whatever the load connected to this complicated network. So this load you can vary time to time, and this network now consisting of VTH and RTH represents this complicated network. Okay, so this is your original circuit, and according to Thevenin's, your equivalent circuit is this one. So this greatly simplifies the computation when you wish to find values of voltages or currents for several different possible values of load resistance. Means this load resistance we can change every time that load will changes. If it is light, if it is fan, if it is a machine, so every time this load of the circuit changes. but the complicated this network remains the same. Okay, so instead of analyzing every time the current flowing through this load or how much load that appliance is taking, so don't analyze the whole circuit. Better you need to analyze only this equivalent circuit every time. How much current is flowing through this equivalent circuit? That only, and that is the usefulness of this Thevenins theorem. So here the steps for finding the VTH and RTH are there. So for finding, open the circuit at the two terminals A and B, where you wish to connect a load or Thevenin's equivalent circuit. So in this circuit shown, this means removing the load. So this load is removed in between the terminals A and B. Then VTH is the voltage across the two open terminals. Now this load I have removed, and here whatever the open circuit voltage across terminal A and B, that is nothing but your VTH. So apply the voltmeter here. The voltmeter will read now the VOC, that is the VTH. Then RTH. For finding the RTH, it is the resistance looking into the open terminals after removing the load resistance with all the independent sources turned off. So recall that to turn off a voltage source, we need to replace that by a short circuit, or otherwise if it has a certain internal resistance, so replace that voltage source by its internal resistance. And to turn on the current source, we replace it by an open. So when your current source is there, it should be keep it as open circuited there. So in this way, measure the resistance in between the terminals A and B, and it will give you your resistance value Rin, that is your RTH, Thevenin's resistance. So the previous slide said that RTH is the resistance looking into the open terminals of the independent source turned off here. So what about the dependent sources? We don't turn those off. So as shown in the following two examples, how you find RTH, it depends on whether the circuit contains independent source or not. If no dependent source, just combine resistors in the series and parallel to find equivalent resistances. So only we have to whatever the series and parallel combination of the resistors in the circuit. So reduce that in one single resistor. If you have dependent sources, it's trickier. So the goal here to find the Thevenin's equivalent circuit for the circuit. Here a circuit is given. Then we have to find out the Thevenin's equivalent circuit, or means here you have to replace this circuit into a Thevenin's equivalent circuit. Means that circuit will consist of a Thevenin's equivalent voltage source VOC, that is VTH, in series with the RTH. Okay, so this circuit we have to replace. How to replace it? So for that we need to find out first VTH. So for finding the VTH, remove this RL resistance here in between terminal A and B and measure the VTH here. Now theoretically you have to find it out by mesh analysis. So find out the loop current in this first loop, second loop. Once you got the value of I2, you will get the voltage drop. Okay, so that will give you the VTH. Then finding RTH, remove this, look inside the terminals, and whatever the equivalent resistance, after reducing this, you will get the RTH value. So here we found the VTH is equal to 30 volt and RTH is equal to 4 ohm. So far as the load is concerned, the original circuit below is equivalent to the simple circuit on the right. So this is the original circuit, and instead of drawing this whole circuit, instead of analyzing this whole circuit for every time the values of RL, only you need to analyze this equivalent circuit, which consists of a VTH source having 30 volt and RTH is equal to 4 ohm. Now here the RL resistance, this RL will changes. Now one question I will ask you, suppose you need to find the load current IL for 6 different values of RL. Would you rather analyze the left hand circuit 6 times? Will you analyze this circuit 6 times or the right hand circuit 6 times? So what will you do? What will be your answer? Yes, your answer will be you will analyze only this equivalent circuit. We will analyze only this Thevenin's equivalent circuit 6 times instead of analyzing this complicated original circuit. So this is about the Thevenin's theorem. Next time we'll see the next topic. Thank you.